So last thing we're going to look at in section 4.5, which is still on analyzing lines of fit, is basically how we can use a model, okay, to predict what's going to happen. Okay. People try to come up with formulas to predict things all the time. Right? So we just use the calculator to come up with a formula that predicts a pattern for a straight line. Well, other things that people might use to predict formulas, like the weather. They're a lot more complicated, but there's different models, like they talk about on TV. Like sometimes with a hurricane, they say, well, like the European model, is showing the hurricane coming closer to land, but the US model shows the hurricane staying like out to sea. So it's just a prediction of where they think the hurricane might go. So predictions are very helpful because in something like that, people might need to prepare, for a hurricane. So they kind of want to know what the weather is going to be. Right? So there's two types of predictions that we can make when we create a model. Okay? That's where you do the stat and you do the calculate, and it gives you the formula. One type of prediction that we can make is called interpolation, and another one is extrapolation. So I'm going to explain what the difference is between both of those types of predictions. Okay, but they're both predictions as to what you think is going to happen. And then the last thing we're going to talk about is the two words causation and correlation. So when you have two pieces, when you're looking at two things, let's say you look at how much time you spend studying, and you look at the grade you get on the test. We can talk about, is there a correlation between the time that you study and what you get as a grade? And if there is a correlation, is it what we call causal? Okay? Does it have causation? Okay. And I'll explain what that means. All right, so let's start with interpolation. Okay, so on your guided notes, it says when you use a graph or its equation, that's like the formula, to approximate or predict a value between two known values. That's called interpolation. So inter means between, making a prediction between two values that you know. So let's go like this. All right, let's take this here. That. And let's say we use an example like we had before. I think we had one where there was somebody who worked a certain number of hours. And then there was how much money that they made in dollars. Right, so let's say you had something that looked kind of like this. And I'll do one more over there. Okay, so what looks like it? What would you say happens here? The more hours that you work, the more you get paid. It's not a perfect line, but it's pretty close. Now let's say we used the calculator and we had plugged all those points in, and the calculator gave us the formula for the line. Okay, I'm not going to go through that. Let's just estimate it by hand. Let's say our line is about like that. Okay, so this is 0 hours, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hours of work. Right, and let's let the pay going up. And we'll let it be like 10, 20, 30, 40, 50, 60. All right. Do we have a dot on that graph for the person working exactly 4 hours? No. There is no dot for the person working 4 hours. Do we have a dot for the person working 3 hours?
Yes.
Yeah, so if they worked 3 hours, it looks like they made about $30. Do we have a dot for 5 hours?
Yes.
Yeah, what did they make for 5 hours?
40.
About $40. So what we're going to do is we're going to make a prediction for 4 hours. between two that we know. We know 3 and we know 5, so let's try to predict 4. Okay, 4 hours, I would say would be right about there. That's not a dot that was given to me, that's a prediction that I just made based on my line. So if the person works 4 hours, what does the prediction look like they would make?
$35.
Yeah, I'd say about $35. What we just did there, that's called interpolating. We made a prediction based on 2 values that we knew, and we predicted between. Okay. Other type of prediction we can do is extrapolation. So extrapolation is still making a prediction, but it's not a prediction between 2 values that you know. It's a prediction beyond the values that you know. Okay, so on that second blank, you want to write extrapolation. Okay, so I adjusted that just slightly so I could use it for extrapolation. But based on the dots that I have left on the screen, what's the highest amount of hours that I have a dot for?
7.
7. That's the highest one I have a dot for. Well, I want to predict what this person's going to make for 10 hours. Okay? 10 is outside the range. It's beyond all of my data. Okay? So I'm going to make a prediction that's beyond everything. So let's go to 10. Let's go up to right there. And if the person works 10 hours, what does my line predict that they would make? I might need to just number a few more. That'd be 70, 80, 90.
It's like 82.
Yeah, it's a little bit above 80, maybe like 81, 82. I would say that's a good prediction. Okay. So that's called extrapolating, predicting beyond all of your data. The further you try to predict beyond your data, the less reliable the prediction is. Right? Think about the weather. If I try to predict the weather 2 hours from now, do you think I could do that reasonably well? What do you think? Yeah, I could probably predict, if it's going to be sunny, what the temperature might be 2 hours from now. How about a day from now? You think I could predict it pretty well, what the weather might be?
Yeah.
Okay. How about a week from now? Maybe not as good. How about a month from now? No. There's no way I can guarantee you what the weather is going to be exactly a month from now. There's too many things that could change. So the further in the future you try to make a prediction, the less reliable it is. Okay? Right. So any question on those 2 things? And that's what I say in your guided notes. In general, the farther away that you try to make a prediction, the less confidence that you can have in it. You can't really predict the weather a month or a year from now. There's just no way you can really know. But 2 hours from now, yeah, you could do that pretty reliably. Right. Any questions on it? All right, so let's take a look. There's a problem. I don't know if we did the problem or not, but it was in the book, and it said we're going to use a line of best fit. So we're going to assume that the calculator somehow figured this out for us. Somebody put in all the data to basically predict when the next eruption is going to be for this geyser. Anybody ever seen that geyser in Facebook? In Yellowstone?
Oh, no, I heard about that.
Yeah, it's pretty neat. It goes off every so often. It can be somewhat unpredictable when it goes off. Sometimes you drive there and you're like waiting for it to do its thing, and it does it pretty quick. Sometimes you got to wait like an hour. Okay? But this is a formula that's supposed to predict about when it will go off. The formula has 2 letters, y and x. Y is how much time until the next time it goes off, and x is, I think that's the previous eruption duration, yeah. So that's the previous eruption duration. So the idea here is if, let's say the last time that the geyser went off, it was a really long duration. Let's say it went off for like 20 minutes. It almost like it has to recharge. It's gotta like get ready to do its thing again. Well, if it takes a long time, it's gonna take a long time for it to charge back up if it went off for a long time. Now, let's say the previous duration was real short. Like people that were waiting for it, it only went off for a minute. Well, if it only went off for a very, very short time, then it's probably going to go off again soon because it still has like a lot of energy to get rid of. Does that make sense? All right. So Y is the time until the next eruption, and X is the previous eruption duration. Okay. So now it says approximate the eruption duration if the time is 77 minutes. So we just have to decide where the 77 is going to get plugged in. Does the 77 get plugged in for Y, or does it get plugged in for X? 77 is the time until the eruption. So
Y.
that's the Y. Y is time until the eruption. Okay. So any question why the 77 gets plugged in for the Y? Okay, it's not the duration, it's the time. And Y is the time. So let's fill that in. So 77 equals 12.0x plus 35. Okay, so we're using the formula to try to make a prediction about the geyser. We're trying to figure out what we think might happen. This formula is not a guarantee that that's when it's going to happen. It's just a prediction. Sometimes the prediction is off. So how would we solve for x here? Okay, so subtract 35 from both sides. So that's gone. And what's 77 minus 35? 42. And what's our last step to get x by itself?
To divide by 12 on both sides.
Yep, divide both sides by 12. And now we need our calculator to type that in. So we type in 42 divided by 12, and that gives us 3.5. And that's x. What does x stand for in the formula? Yeah, it's the previous eruption duration. So if it takes 77 minutes for the next eruption to happen, then that means the previous one went for about 3.5 minutes. Right? So that's what x is. So x is 3.5 minutes. All right, now the next one is a little bit different. This is the one I think most people would be more interested in if you were visiting Yellowstone. That's where the guy is. How long until the next eruption? Because you want to know. All right, it's 10 o'clock. When's the next one? Is it 40 minutes from now? Okay, so then I want to try to be there maybe by 10:30 so I can watch it. It says the previous eruption duration was 5 minutes. We have to decide where that 5 is going to go. The 5 is the previous duration. What letter in the formula is the previous duration?
X.
That's the x. So now the 5 is my x. So let's fill it in. Y equals 12.0 times x, the previous duration. Okay, what was the previous eruption duration here? 5. So fill in 5. And what goes on the end of the formula?
35.
Yep, plus 35. So this 35 and the 12, that's what the graphing calculator would give you. It would tell you when you type in all the data, it would calculate that. So we didn't do it this time. Right. So let's figure out what this is. What's 12 times 5? 60. And what's 60 plus 35?
95.
95. And what letter did we just plug in for?
Y.
Like this is what we plugged in right here.
Yeah, we plugged in X.
We plugged in for x and we solved for y. So y is the time until the next eruption. So the next eruption is going to happen in 95 what? Minutes. It's 95 minutes. Okay, so if you want to make sure you see it, you should probably get there in like 60 minutes. You probably get there a half hour early, just in case. But that's when it should roughly happen. So any question on using a formula that you're given to make predictions? And you can make predictions either way. You can plug in for the x and predict the y, or you can plug in for the y and predict the x. We did both. Okay. All right, so now, example 2. Okay, another formula that is being given to you. Again, where would these numbers come from? Somebody can use a graphing calculator and figure them out. Okay, so that part's already been done. It says, use the line of best fit to predict the following. So I think what this formula does is it predicts how many teachers a school has based on how many students are in the school. What would you think would happen? If a student has more students, you would think that there would be what? More teachers, you would think, right? A school with 4,000 students, you would think has more teachers than a school with 500 students. You know, you think. So this formula calculates that. All right, so we're going to make a prediction. It says how many students would be at a school that has 20 teachers. So we're going to make a prediction of how many students would be at the school. Where would the 20 get filled in? Is the 20 x or y?
The Y?
So what's the 20? It's 20 what? 20 teachers.
Yeah.
Which one is teachers? X. So we're going to take 20 teachers and fill that in for x. And what is y again? Y is the students. So based on a school having 20 teachers, we're going to predict how many students are in the school. So fill in 20 for teachers and plus 42. Okay. What's 21 times 20? More than 80.
420.
420, yeah. And what's 420 plus 42?
That is 462.
462. And what did we just solve for? 462 what?
Teachers.
Well, we were given 20 teachers. We solved for students. So based on some data, maybe somebody surveyed like 100 different schools. They put all that data into the graphing calculator, came up with that formula. And based on that formula, a school with 20 teachers would have 462 students. All right, now let's try this. How many teachers would be at a school that has 335 students? Okay, 335 students. Where is the 335 going to get plugged in?
Y.
That's y. So let's fill that in. So 335 equals 21x plus 42. And what are we solving for this time? Solving for x, which is
How many teachers?
how many teachers. Okay, they told us how many students. We're finding how many teachers should be at the school based on the formula. Okay, what's our first step?
Subtract 42 from both sides.
Subtract 42. Okay, and 335 minus 42,
Is 293.
293. And my last step,
Divide by 21.
divide by 21. And I need a calculator for that. So 293 divided by 21 means there would be about how many students at the school?
14.
About 14. I'm sorry, teachers. About 14 teachers. So right, so based on the data, if your school had 293 students, you probably need about 14 teachers to teach all students. Okay. Any question on that? Yes.
This used to be ordered. This feels kind of easy.
Yeah, it's usually pretty easy to make a prediction once you have a formula.
Yeah.
Yeah. Sometimes figuring out the formula can be hard. Depends on the data, but we have a graphing calculator to figure the formula out for us. Doing that by hand is a lot harder. All right, now let's think about this for a second. Teachers and students. Do we think there is a connection between how many students a school has and how many teachers it has?
Yes.
Yeah, what would you say the connection would be?
Ratio.
Well, if you were to describe the connection, what is the connection between how many students and how many teachers?
However many teachers become however many students.
How about in terms of, like if you have more students, what do you think would happen?
You'd have to have more teachers.
Right, you'd have more teachers, okay? So we think that there's a connection between how many students and how many teachers. That's called a correlation. If we think that there could be a connection between two things. Now, is it automatic if 20 new students enroll today at Monty Tech, is it automatically going to have a new teacher today? No, that's not automatic. Just because we get new students, it doesn't automatically mean, boom, there's a new teacher all of a sudden. Okay? If something happens automatically, that's called causation. When one thing changes, the other thing has to change automatically. Right? So let's write those two things down and then go through some examples. Okay, so on the back where it says, when a change in one variable automatically causes a change in another variable, that's called causation. Okay. Here's an example of causation. Let's say you're exercising on a treadmill. Right? The more time that you spend on the treadmill, what do you think is going to happen to the number of calories?
Goes down.
Increases.
Like the number of calories you burn.
Decrease. Goes up.
Wait, what?
Like the more time you stay on the treadmill,
The
It's
more
gonna-
calories you burn.
the more calories you're going to burn. Right? Now, that's causation because if you stay on the treadmill for 20 minutes versus 10 minutes, you are guaranteed you're going to burn more calories. There's no way around it. Assuming you don't change your speed, you don't change the incline, you keep everything else the same. Right? If you stay on the treadmill more time, you are automatically going to burn more calories. You can't not. It's just causation. More time on the treadmill, more calories are burned. That's different than the number of students and teachers in a school. If you get more students, you don't automatically get a new teacher. There might be a connection between the two, but it's not automatic. Okay? Causation means it's automatic. So causation means that there is a strong correlation between the two variables, and you guys already have that written on your guided notes. All right? But just because two things might have a connection, it doesn't automatically mean one changes the other. Okay? So when you think causation, think of the word automatic. If one thing changes, the other thing automatically has to change. And that can be up to interpretation sometimes. Okay, this week is really all about like statistics. So when you're doing statistics, there's a lot of interpretation. How do you think about the data? Okay, sometimes people have certain biases when they look at data. They don't even realize they have. So I'm trying to give you situations that are more black and white. Okay, situations that are clear cut. But realize when you really do statistics, a lot of things are not black and white. There's a lot of room for how you interpret it. All right, so example 3 says, tell whether there is a correlation. Remember, correlation just means, do you think there's a connection? Do you think as one thing changes, something else would likely change? If there is, then tell me if it's causal. That means if one thing changes, the other thing has to change. It's automatic. Okay. All right. Well, kind of did this one. So the time spent exercising and the number of calories that you burned. Do you think there's a connection between the two? And the way you ask yourself is you say, okay, if I spend more time, will I burn more calories? Yeah, I would say there is a connection. So let's write down, yes, there is a correlation. So that answers the first part. If there's no correlation, you don't even have to do the second part. If there's no connection between the data, then it's definitely not going to be causal. It can't be. All right? So first say, do you think there's a connection? And if there is it automatic? Okay, what did we say about this? If you spend more time exercising, will the number of calories automatically go up? Yes. You know, given you do the same exercise at the same speed, don't change anything else. But if you're spending more time exercising, the number of calories burned will go up. So I'd say yes, there's a correlation, and this is causal because if you exercise longer, you automatically burn more calories. There's no way you have to. You automatically burn more calories. Okay, here's another one. Let's say you're driving in your car, and I ask you, do you think there's a connection between the amount of time you drive in the car and how much gas is left in the car? What do you think?
Yes.
What do you think would happen? The more time you drive, what would happen to the gas?
The less gas you have.
The less gas you have. There'd be a negative correlation. The more time you drive, the less gas you have. Now, do you think it would be causal? If you're driving the car, say the speed stays the same, the slope of the road stays the same, if everything stays the same, if you drive the car longer, will you automatically have less gas?
Yes.
Yes, you will. There's no way around it. So that is a causal relationship.
Unless you put it in neutral.
Yeah, you got to keep everything the same.
Okay.
So yeah, keep everything the same. Same speed, same road. If you drive longer, you will have less gas. That's causal. No way around it. It's automatic. All right, how about this one? The number of banks and the population of a city, or like the size of the city. Do you think that there could be some kind of connection between how big a city is and how many banks are in the city?
No.
No? Okay, how come?
Because you could have 1,000,000 banks in the city and have one person, but you could have 1,000,000 people in one bank. So it's not automatic.
Right, it's not automatic. But what do you think if we we went online and we looked up how many banks in Boston, how many banks in New York, how many banks in San Francisco, how many banks in Los Angeles, and then we compared that to how many banks in Rutland, how many banks in Hubbardston, how many banks in Westminster. Do you think there would be a pattern with the bigger cities?
Yeah.
What do you think would happen?
There's more banks.
There probably would be more banks in those bigger cities, I bet. I mean, I could be wrong. But I think a city like New York is going to have a lot more banks in it than a city like Rutland. There's a lot more people. It's a lot bigger city. But it's definitely not causal. It's not automatic. So you could argue it different ways, but I would argue that is there a correlation? I would say yes. A bigger city, so let's say a bigger city is likely, it's not a guarantee, but it's likely to have more banks. But is it causal?
No.
No. Just like having more students in a school doesn't automatically mean a new teacher just pops up. Doesn't work that way. Okay, so is it causal? It is not automatic. It is not causal. More people does not automatically mean more banks. Any question on that? So I'd say there could be a correlation, likely, but not causal. All right, let's try a couple more. So example 4, tell whether there is a correlation. If there's no correlation, you can stop. There's nothing else you need to do. But if there is a correlation, is it automatic? The amount of time spent talking on a cell phone and the amount of battery left. Okay. What do you think in general would happen as you talk, as you use the phone more? What do you think would happen to the battery life?
It will go down.
Yeah, I would say, yeah, in general, it would go down. Yeah, this is assuming it's not plugged in. It's not charging. It's not plugged in. You're just using it. Now, is that automatic? If you use the phone more, will the amount of battery left go down?
Yes.
Yeah. Assuming you don't plug it in and then all of a sudden it starts to go back up. You don't put it in like power save mode. Assuming you use it the same way. If you talk for more time on the phone, the battery will automatically drop. Okay, any question on that one, or if anybody thinks differently, you can let me know that. I can try to talk about it, but I think that's a very black and white one. The bank one was a little bit more room for interpretation, but this one definitely not. All right, how about this one? The height of a toddler and the size of their vocabulary. No, I don't think there'd be any connection at all between how tall a toddler isn't necessarily the number of words they know. You might have a toddler that grows faster and a toddler that grows slower. Some people, grow at different rates. So I don't necessarily think there'd be a strong correlation between the height and how many words somebody knows. Maybe somebody has a parent that reads to them every night and then they learn a lot more words. Maybe somebody doesn't. I don't know. So I would say that I don't think you'd find a very strong correlation between height and vocabulary. So if there is no correlation, could it be causal? No, definitely not. Just because you grow 1 inch doesn't mean you automatically now know 200 new vocabulary words. It doesn't work that way at all. So I would argue no for both of those. Does anybody have any other thoughts or think differently? Now, what if they worded it a little differently? Like let's say they said like the number of days old or number of months old a baby is and how much they weigh. What do you think about that one?
Yes.
How many months old and how much they weigh? You think there'd be a connection there? Yeah, I would definitely say that's a correlation. And in fact, doctors look for that because if your baby isn't hitting certain like weight thresholds by certain months, they might get a little concerned if the baby is really underweight. So there is a trend that babies should roughly follow within a certain margin of error for how quickly they gain weight. Yeah. At a certain point, that kind of levels off, right? You don't just keep gaining weight forever. It's impossible. At some point, you can't keep growing at the same rate as a little baby. It just doesn't happen. All right, let's look at this one. The weight of a dog and the length of its tail. Do you think there would be a connection between how heavy a dog is and how long their tail is? No. Why would there? I don't think there would necessarily be a connection between those two things. So if there's no correlation, can the correlation be automatic? No. If there's no correlation, it's definitely not causal. Now, something that might have a correlation is if you say how long the dog is and how much they weigh. I would say that a longer dog probably weighs more than a shorter dog, most of the time. But not with this. Okay. Any questions on that? So that's kind of a little bit of a sample of some statistics stuff, and that's all we really do in this class with statistics. And I think that finished up chapter 4. All right, so just a reminder, the worksheet for tonight is 4.5, part 2. And tomorrow is going to be a review day, so make sure you bring your Chromebook, and we'll go over the homework, and then you'll have the rest of the period to work on a study guide for the test. I will also be after school tomorrow in case anybody needs to come by for extra help.